started a speaker series this semester. Our first speaker was Mike Reed with White Pine Power, who came and talked to us about biomass cogeneration and what that could look like for Michigan Tech University. And Alman is the second in our series, and we're very happy to be able to put this together for you. Also, in 2 weeks on April 7th, we're going to be having Jonah Levine, who's going to be coming and talking about integration of electrical generation resources for the next generation utility. So we are thinking of having that in this room as well, although we might end up moving it over to the media center room. I think that's the term for it. So I hope you will join me in welcoming Amon.
Well, thank you, Melissa. And so today, I'm going to be talking about a systems approach to studying sustainability in the built environment. And it's great to have all of you here because I think at some point of time or the other, I've had discussions which of part of this or all of this, all the ideas presented today. And I've also worked individually with a lot of people in the room towards some of the components of this talk. So a lot of this is, some of the ideas are not necessarily complete. Some of them are more for presentation and dialogue. So stop me, eggs, tomatoes, anything, welcome, because I'm looking forward to any kind of criticism. Primarily the work behind it, all my students, all the students I've worked with, and Helen, a lot of her PhD work, Yong Liang, he's kind of doing some new stuff with that too. And in various different ways, the simulations work that I've done with Matt and Ryan, and Daryl, who's the newest member to our group starting in summer. So, and then Pei is kind of, he's there and he's kind of starting with certain different aspects of the simulations part too. So the outline is, what I want to present today is, typically when we talk about sustainability, we talk about the triple bottom line, and then we talk about societal, economic, and environmental contexts. And one way or another, there always are various conflicts that come in trying to bring all the three parts of the bottom line together. And so, well, I did make a promise that I wouldn't use the word triple bottom line today, but can we move away from the triple bottom line and instead use a more systems approach? And then, of course, I'm going to limit my talk to the built environment, which, as we'll see, is actually quite a broad area in itself. And with a few examples, talk about what this, how we could go about methodology called sustainability. So, and then, of course, we'll discuss representation within that method, how we can use the method to explain existing systems, and also develop prediction tools. Typically, right now, the challenges with respect to sustainability is that at a conceptual level, the idea is fairly accessible. And we all believe in it. We all think it's important. Whether we're in academia or whether we're in industry, there is a strong understanding that this is something that needs to be done. But after that, we kind of, that's where the divisions start, because people start stepping on each other's toes. There are different stakeholder interests that come into question. And while it's an idea that's conceptually accessible, when it comes to implementation, it becomes fairly difficult. And then, of course, there is also the opinion, yes? I don't know. It is? Okay.
Yeah, that's not for the room, that's just for the camera, not for
Oh,
the
okay.
VA.
Oh, okay.
There you are.
Voice just from the front, that's fine.
Okay. Well, so there's also the other idea within the design community. Well, is this just, is this old wine in new bottle? Weren't we already taught that when we did our designs that you had to make sure that you were economic about your design, and you had to make sure that your impacts were low. So is this really just old wine in new bottle and plain old good design? So where I'd like to start off, and this is one of my favorite, this is an idea that I find very inspiring, and I started my dissertation with this, and various papers I've started with this idea, is the idea of different perspectives. And you kind of fall back on scientific method and the history of science. And you realize the reductionist paradigm, which is kind of where most of modern scientific methodology is based on, it comes, of course, it has roots in Newton Cartesian philosophy, the so-called Newtonian worldview, where you start off with the assumption that the whole is a sum of the parts, which basically means that you can reduce your problem down to small subparts. You focus on what can be measured, and then after that, once you've solved each of these subparts, you bring them all back together, and you hope that, well, as you bring them all back together, the solution to the whole becomes the sum of the solutions to the parts. Then there is a systemic or more holistic point of view, which I have a personal interest in philosophy and religion, but if you go back to various traditional philosophies and traditional religions, you'll find that the systemic line of thinking has always had its roots in pretty much almost all ancient cultures. And it's interesting how if you just look at the idea of where reductionist thinking came into play, and also if you look at environmental degradation, the rate at which environmental degradation started off, it's almost directly in direct correlation to Newton-Cartesian thinking coming into play. Now, having said that, of course, and we'll be talking more about these two paradigms as we go on. Having said that, I mean, we should not forget at any point of time that the reductionist paradigm in itself has brought us, it's resulted in significant developments in engineering and technology. But at the same time, what it's also done is it's led us to a point where when we formulate our problem formulation is very disciplinary. So we tend to say, we look at a problem and say, well, is this a computer science problem, or is this a mechanical engineering problem, or is this a civil engineering problem? And then within each of these disciplines, we have our own different methods and sometimes very different ways of handling the same problem. Okay. Also, the methodology has focused on measurable quantities. Okay. If it's not directly identifiable, measurable, and results in direct operational metrics, we don't talk about it. So we love simplicity. We do not embrace complexity. Okay. And most of the time, it's because we don't have the necessary language or the tools to embrace that complexity. But however, as we've been solving some of these components, some of these smaller problems, we're at a time. We talk about interdisciplinary thinking taking a big step in the last a number of years, but that's also partly because we've come to a point where slowly these reductionist problems are actually hitting up against each other, and we literally need to talk about what are all the other problems that I'm creating or helping in solving as I'm solving my own problems. And in the process, we're moving towards a problem formulation where there is a greater acknowledgement of interdependencies, and also focus on relationships where sometimes we're basically just acknowledging that there exists relationships, some of which can be very difficult to quantify. So as a result, the impact of this is that there is a greater inclusion of context, as opposed to the reductionist paradigm, which kind of led to a disconnect between the abstract and the material world. So it's kind of, I think, therefore I am. So you take your mind away from the material world. And similarly, the problem from the context. Compared to that, within the systemic paradigm, you're reinforcing the context back in. And you're saying that you recognize complex behavior and you start thinking, instead of in direct linear terms of causality, in terms of complexity, ideas of emergence and self-organization.